Good morning. Today we will talk about the two types of testing. The processes are z-test and t-test. So as we are going through the lecture note, I want you to remember and understand when to do what test. If the population standard deviation sigma is given in the context, then you do z-test. And if the sample standard deviation s is given, then you do t-test. As we discussed in last class, you will do the testing in order to either accept or reject a null hypothesis. What do I mean by that? Say, you know there exists an existing population mean. I know that for a certain thing, the population mean is already there. I did a statistical study and now I want to either replace the existing statistical mean and establish my found new mean, or I will not replace the existing statistical mean and I will ignore the mean that I found out, but I will do this thing statistically, and that process is called testing. So what did I say? There is an existing mean, so mu naught is already there. I found a mu. Either I will reject the existing mean, so that will go away and mu will take place of that, or I will say that no, I'm going to accept the old existing mean and I'm going to reject mine. The new one, the mine that I found the mean, I'm going to reject it. And that's called rejecting the null hypothesis or accepting the null hypothesis or not rejecting the null hypothesis. So I need the existing mean, which I'm going to call H naught as my original existing mean null hypothesis. And then I will use my new mean as an alternative hypothesis. In testing, we can think of three different testing depending on the language of the testing. So if I say the new mean is greater than the old mean, it is called right-hand testing. If I say the new mean is less than the old mean, it is called left-hand testing. And if I say the new mean is not equal to, not specify whether it's greater or less, it is just not equal to the old mean, it is called both-sided testing. So what is the procedure of doing testing? The first information I need to know is called the Z data, the Z statistics or the Z data. And it is the new mean you found, X bar, minus mu naught, the existing mean, over the sample size square root of n over the population standard deviation sigma. So that is called the Z data, which I will need for any testing, or Z statistics is also one other name of this information. And I will then go ahead and find the critical region. And again, depending on whether you are doing left-sided test or right-sided test or both-sided test, your critical region is going to be different. Every testing will be done with a significance level. Significance level is the alpha value. So what we will do if we are given with a significance level and we are doing one-sided test, in Z testing, we're going to refer back to the Z table. So let's talk about this testing process a little bit more. So as I said, the critical region consists of the range of values of the test statistics Z data for which we reject the null hypothesis. The non-critical region consists of the range of values of the test statistics Z data for which we do not reject the null hypothesis. The value of Z that separates the critical region from the non-critical region is called the critical value or Z critical. It's like finding the Z alpha over 2 information. The Z test for population mean is going to be a critical value method that we're going to adopt in our class. And we will do it if we know that the population is normally distributed or the sample size is greater or equal to 30. First step, state the hypothesis including null and alternative hypothesis. Step 2, find the critical data and state the rejection rule. Use the given level of significance in order to find the critical data, and then calculate Z data Finally, state the conclusion and interpretation. If the Z data falls in the critical region, reject the null hypothesis. Otherwise, do not reject the null hypothesis and interpret accordingly. Now, this process sounds a little bit of critical when we are to think about the process, but let's try to solve problem. And if you understand normal distribution a little better, then this is not at all difficult. And as usual, I will first show you how to simplify this problem using analytic methods, using hand on your own. Then we will use Excel spreadsheet and we will learn good processes. So it is about household sizes. The US Census Bureau reports that the mean household size equals 2.58%. So this is your existing mean. You're going to say that mu naught is 2.58. A random sample of 900 households. So sample size is pretty big, 900. We will do the testing. Provides a mean size of 2.56%. So this 2.56 is your challenger. It is the sample mean, the new mean. Assume that the population standard deviation sigma is 0.6. Conduct a hypothesis testing using the level of significance of 0.10. So it has been given that the level of significance is 0.10. Whether the population mean household size this year is less than 2.58, and this is very important in order to understand your hypothesis. So what I say? First I say null hypothesis. That is, the existing mean mu naught is equal to 2.58. Then the challenger is the alternate hypothesis, which is the existing mean is greater, or the new mean that we found out, the population mean that we found out, should be less than 2.58. So what do you write? Your new mean mu is less than 2.58. So as soon as you have said that, you will say you will do a z-test. Why you will do a z-test? As population standard deviation sigma is given. So just follow these steps. I wrote down my hypothesis. I understood that I'm going to do a z-test as the population standard deviation is given. What type of z-test? Remember, it is telling me that the new contender mean is less than the existing mean. Less means you are on the left hand side. So you are doing a left tail test. So now I will say it is a left tail test, and that changes the diagram, helps us understand how to find the critical region. How do I know it is a left tail test? Because of this word that the new found mean is less than the existing mean. So very important that you read the problem. Left tail test. So what it signifies? I want to know Z critical. I want to know the critical number on the number line, so that the left hand side of Z critical is the significance of the testing, which is 0.10. So this area is 0.10. Now I know the process. I'm going to find the Z critical. The Z critical is going to be the Z score that is responsible for the area 0.10 on the left hand side. So let's try to find it out. We'll go to our standard normal table and find 0.10 on the standard normal table. Let's try to find it. 0.10, I think we will not find it as far as I remember from previous classes. In fact, I don't think I have that. I have those two numbers, 0.1003 and 0.0985. So wanted 0.1, didn't find it, rather find 0.1003 and 0.0985. Remember, the process is you find the z-score for either of them. So let's see what are the z-scores. For 0.1003, the z-score is negative 1.28, and for 0.0985, it's negative 1.29. So this is negative 1.28, negative 1.29. I'm going to add these two z-scores in order to know the Z critical number and divide by 2, which will give me negative 1.285. That's this one, negative 1.285. I'm going to use the red marker to say anything to the left of the Z critical value is the critical region. So this portion is going to be called the critical region or the rejection region. The final step is to find the Z data. The Z data, as you can recall the formula, is whatever is your new sample mean, x bar, minus old sample population mean, mu naught, over sigma over square root of n. So let's do that. New sample mean is 2.56 minus old sample mean is 2.58 over sigma, which is 0.6, all over square root of the sample size 900. So this is what I'm trying to find out to understand as the Z data. And of course, I'm going to use the calculator in order to understand this quantity. So let's see what we get. So first let's do the denominator first. So I have, in the denominator, I have 0.6 over square root of 900. So we'll do 0.6 divided by square root of 900. And that is 0.02. And then on the top you have 2.56 minus 2.58. So negative 0.02, and I'm dividing it by 0.02. So that is going to give me negative 1. So once I have that, I have my Z data. My Z data is negative 1. So what we will do now, we will identify this Z data on the critical region or outside the critical region. Remember, the critical point is negative 1.285. It is standard normal, so this value is 0. So negative 1 actually doesn't fall on the critical region. It falls here, somewhere here between negative 1.285. So this is your Z data, negative 1. So it is not in the critical region or the rejection region. So we say that we are not going to reject the null hypothesis. I did the testing, but the testing tells me whatever the existing population mean was is going to stay, not rejecting H naught. So we had the idea that the population mean might have changed. It might have lowered to 2.56, which is not true for the population. And how do I interpret this answer? So always when you do testing, be very careful about your interpretation. So we'll say, at the significance level of 0.10, so 0.10 significance actually means 90% confidence. So these are related. I just wanted you to know that. At the significance level of 0.10, there is not enough evidence. So when we do not reject the null hypothesis, we say there is not enough evidence to reject the null hypothesis mu naught is equal to 2.58. So I'm not being able to reject it because lack of enough evidence. That is your basic process of testing. So again, what we will do now, we will sum up the process of testing before we go ahead and do other problems. And I will sum it up for Z testing, and we will use the exact same technique for T testing. So first thing first, read the problem. The situation. Find mu naught, that is the existing population mean, and as I have already said, this is for Z test. So when I do Z test, if sigma is given, then and only then I will do the Z test. Okay, what else? Then you create your null hypothesis, and that is basically H naught. You will say mu naught equal to whatever given information is given to you. So you will write that down. H alpha will be threefold. Either you will find out that it is saying mu is less than mu naught. That will be 1, and you do left tail test. So what is left tail test? As soon as you are doing left tail test, draw the diagram, find the Z critical. See how I'm pointing things out. This is going to be the significance, the given significance in the problem, which you will also call the rejection region or the critical region. And then we can have mu greater than mu naught depending on the language of the problem. This is the right tail test. If I have a right tail test, as you can imagine, the picture is going to be on the right hand side. So we'll say this is going to be Z critical at that point, and the area on the right will be the significance. So you have to be a little critical here when we're finding the Z critical value. And this region is, of course, the critical region or the rejection region. And the final one is, if I do not specify whether mu is less than mu naught or mu is greater than mu naught, I just say mu is not equal to mu naught. In that situation, I do both tail test. What does this mean? It means you will get 2 critical points. You will get one on the right, Z critical, and one on the left, Z critical, but these are symmetric, so one is negative, the other is positive. And on either side, I will get significance over 2. Significance over 2. And this is also significance over 2. And as you can imagine, this is a rejection region or critical region. This is also rejection region or critical region. What else I need to know is the final thing, that is the test statistics. Which is the Z data. In Z test we call it Z data, in T test we will call it T data, but the rest of the process is exactly the same. So Z data is given by Z equal to, so we'll call it Z data, if it is the new mean minus the existing mean over the population standard deviation over the square root of the sample size. And if your Z data is in rejection, if it is in the rejection region, then reject null hypothesis. And you know, we call the null hypothesis by writing H naught. If it is not in the rejection region, so if Z data, it is not in the rejection region, then do not reject the null hypothesis. H naught. So that's the basic way for doing the testing. As I said, the T test will be done when sample standard deviation is given instead of the population standard deviation, but the process, there is absolutely no change. So let's go back and try to do some problems, more problems with testing. So we'll go to our next page. Americans' height, a random sample of 400 Americans. So as soon as I read, I write down the information. N is 400. Yields a mean height of 176. So sample yields the mean, means this is your X bar, 176 centimeters. Assume that sigma, so sigma is given, we are doing Z test, 2.5. Conduct a hypothesis test to investigate whether the population mean height of American has changed from 175 centimeters. So the existing mean, mu naught, is 175 centimeter. But this time, see, I did not say whether it is greater or less. I said just not changed. So I want to see whether it has changed from 175 centimeters or it did not change at the significance of 0.10. So because of this, I will say I'm doing both test. Because of sigma, I will say I'm doing z-test. So as I have said, you will draw the picture first. To identify the rejection region, we will get two of these rejection regions. Both of them I'm going to call Z critical. And then see what I do. I shade them in red, the critical regions. And remember, either of them are going to be significance over 2. So this is going to be 0.05. That's 0.10 over 2. And that's 0.05. So both areas are 0.05. Now what? We're going to find Z critical. So we can just find this one on the left that will come directly from your standard normal table. So let's go to standard normal table and find the area 0.05. So let's see where we get that. 0.05 is not present again. You have 0.0505 and you have 0.0495. So you wanted 0.05. You did not get it, rather you got 0.0505 and 0.0495. We want both z-scores, and these z-scores are negative 1.6, 0, 1, 2, 3, 4, and 5. So we'll say that this is negative 1.64 and this is negative 1.65. We'll add them, and remember these are the z-scores, which will give me the Z critical, and then I divide by 2. So I get negative 1.645. As soon as I have done it, I will say that this one is negative 1.645, and this one is symmetric but positive, so 1.645. So we have our rejection regions with our critical numbers. So now it is time to find the test statistics, which is the Z data. And remember, Z data is going to be found from the formula x bar, which is 176, minus mu naught, which is 175, over sigma, which is 2.5, all over square root of the sample size, 400. Whereas we will remind ourselves what was the null hypothesis. The null hypothesis was existing mean is equal to 175. And the challenger is the alternate hypothesis. Mu is not equal to mu naught, and that has told you to do the two-tail test or both tail test. So let's find out the Z data. We will evaluate 2.5 over square root of 400 first. So in our calculator, go ahead and say 2.5 divide by the square root of 400, which is 0.125. And on the top, we have 176. The existing mean is 175. And so we get 1 and we divide it by 0.125. So I get 8. So let's find out the location of this Z data on the rejection table. So this one is 8. And see, this is 1.645. So 8 will be way up here. So clearly this one is going to be in the rejection region. That should be somewhere on the right of the critical point. So this is in the rejection region. So you will say reject. The result of the testing is reject the null hypothesis. But I'm going to write it in the proper way of interpretation. So we're going to say that. Hence, at the level of significance, and remember it is 0.10 again, we have enough evidence this time to reject the null hypothesis H naught, which says the existing mean is 175 centimeters. So the American height most possibly has changed. What if the population standard deviation sigma is not given? Instead, the sample standard deviation S is given, and then we are going to do the t-test. But we don't have to spend as much time learning t-test because I said that the processes of testing are exactly the same. Before we go to the rest of the problems, let's try to see what we can do using the Excel spreadsheets. So the first problem that we did, we were doing z-test. So if you go to your Excel spreadsheet, there is a z-test spreadsheet. Open it, read how to inform and fill in the blanks. So when I go to this block, it says that change only the sample size B1. So first you're going to say change the sample size B1. So sample size B1 is here. Then sample mean G1. So we're going to change the sample mean. And then population mean B2, which will be here. That's the existing mean. And then you're going to say population standard deviation. So let's see, what does this say? So if I cannot see it, I just have to make it a little bigger to read all of that. So population standard deviation in D2, that's the other information you're going to put it here. Alternative hypothesis. So this one is important. So read the instructions in E2, and then significance is also going to be changed in C3. So we'll go to E2, which is here. It says insert -1 if you're doing left tail test, insert 1 if you're doing right tail test, insert 0 if you're doing both tail test. So now think about our problem that we did. We were doing a left tail test on this one. So let's go ahead and fill in the information. Left tail, so I will say it's -1. Then the other information is change the sample size B1, and the sample size in this problem is 900. So we're going to do that. I will say sample size is 900. It said sample mean should be changed. Sample mean is the new mean, the contender mean, and that is 2.56. So I will say that this is 2.56. We will also change the population mean in B2, and the population mean is the existing mean, which is 2.58. So we'll go ahead and change it to 2.58. We'll change the population standard deviation because we're doing the z-test. It is given, and that's 0.6. And we have to change the level of significance. And the level of significance was 0.10, which is already there. So we're pretty set. So if I want to compare the information we found out, first we want to understand what will be the z critical value. See, rounded to 2 decimal places, it is -1.28. So I do have -1.28 as my critical value. What else we found out? We have seen that the z data is -1. So let's check that. Z data we found is -1, and then see, this one is actually telling you what is going to happen in the testing. There is not enough evidence at the level of significance 0.1 that the null hypothesis can be rejected. So do not reject the null hypothesis. So it's pretty concise the way this spreadsheet is going to work. Okay, so let's check our next problem that we have done. This time we did a both tail test. So we will first go ahead and change it. It said both tails should get the insert of 0, and in this problem our sample mean was 176, existing mean or population mean is 175. So sample mean is 176 and population mean is 175. Standard deviation was 2.5 and significance is 0.1. So we'll change standard deviation to 2.5, significance is 0.1. The last information is the sample size, and the sample size is 400 for this problem. So doing both tail test, critical values are -1.64 and 1.64, which was pretty close in our work, -1.64 and 1.64. We found out that the z data is 8. We found the z data is 8 as well. And then finally, we will say that it looks like I said D. I will fix it. I will make it 8. And finally, what we will do, we will read the conclusion of the testing and see it says that there is enough evidence at the level of significance of 0.1 that the null hypothesis can be rejected. So we said that, reject the null hypothesis. Alrighty, so I don't know why I wrote D for the Z data. Clearly we calculated and it was 8. So I will change it, and it has erased a bunch of other things. So let's see what we have. We said reject the null hypothesis at the level of, this should be significance 0.10. We have enough evidence to reject the null hypothesis. Alrighty, so let's think about the other problems and see why we are encouraged to do the t-testing. iPhone apps. According to a 2010 Nielsen survey, the mean number of apps downloaded by iPhone users is 40. So the survey says that it is 40 in 2010. So I will say that that's the existing mean. So existing mean mu naught is 40. Suppose a sample of 36 iPhones. So the sample is of size 36. 36 iPhone users downloaded on an average of 45 apps. So this is your new mean, average of 45 apps. With a standard deviation, see how it says it is coming from the sample? Sample of 36 iPhone users downloaded mean of 45 apps with the standard deviation of 24. So this is S. So I need to do t-test. And for t-test, I'm not going to work it out. I will just use the spreadsheet, the t-test spreadsheet, and show you how it works. Okay, what else? It is telling us to test whether the population mean number of apps is greater than 40. So now I want greater than 40. So this means I should do a right-tail test at the level of significance of 0.10. So what we do, we write the null hypothesis, that is the existing mean is 40. Alternate is saying the new mean has exceeded the existing mean of 40. It's greater. Then we draw the right tail picture. Remember, you are doing t-test because the sample standard deviation is given. So on the right tail, you call it t-critical. That's what you are trying to find out. And I will find it from the spreadsheet. And what I will do, I will shade the rejection region. So this is the rejection region in this problem, or the critical region. And the rest we're going to do all on spreadsheet. So the next information is finding the t data, and the formula for finding the t data is exactly the same. It's x bar minus mu naught. Instead of sigma, use s over square root of n. But I'm not going to work it out. I will put information in my t-test spreadsheet and all the work will be done there. So let's go there, and you are using the t-test. So it's pretty similar. It said that if you're doing left tail, use -1. If you're doing right tail, use 1. Insert 0 for both tails. So I'm going to use 1 because this is a right tail test. Change sample mean. Sample mean in our problem is 45. This problem said that the sample mean is 45. The population mean is 40. Then the sample size is 36 iPhone users. Changes the degree of freedom automatically. And then standard deviation is, for this problem, is 12. Oh, actually 24. The standard deviation given is 24. So we'll go there and change it to 24. Level of significance is the other information that you will need. And the level of significance is 0.10. So we'll go ahead and say that this is 0.10. And then it says that the critical value is 1 point, round to 4 decimal places, 1.3062. This is 1.3062. The t data is also calculated, and the t data for this problem is 1.25. So we'll go ahead and say that t data is 1.25. Is 1.25 in the rejection region? Well, no, because 1.25 will be less than your critical number, so it is on the left of the rejection region. This is your t data, 1.25. So that tells me I do not have enough evidence. I'm not going to reject the null. So do not reject the null hypothesis. That's the result of the testing, and you are writing the interpretation. So you say at the level of significance, there is not, I'm so sorry, it should be there is not enough evidence to reject the null hypothesis, which is the existing mean number of average app downloaded is 40. We will not reject it. And I'm pretty sure if you look at the spreadsheet, it will clearly tell you that this is the result of the testing. I just wanted you to see on your very eyes how to do it, even if you do not have the interpretation. So there is not enough evidence at the level of significance of 0.1 that the alternate hypothesis is correct. Alrighty, so we have one more problem, and let's try to do that. This is about the US Census Bureau reports that the average number of employees in small business is 16.1. As soon as I read that, I tell myself I know the existing mean. It's 16.1. Suppose a sample of 49 small business showed a mean of 15 employees. So this is from the sample. Sample size is 49, and you know that the sample mean is 15 with a standard deviation of 25. So now I know S is 25. Why I say S, not sigma? Because it says with a standard deviation, which is coming from the sample of 49 small businesses. So it's a sample standard deviation. As soon as I have read that, I will say I do t-test. Test whether the population mean number of employees in small business is different. See, it didn't say greater or less, it said different. So you do two-tell or both-tell test. And at the level of significance of 0.01. So this one is a different level of significance. And I will say that this is 0.01. So what I do, I draw the picture. So H naught, the null hypothesis, is existing mean is 16.1. The challenger alternate hypothesis says mu is not equal to the existing mean. I'm not sure, greater or less. So I will do both tell test, and I will get two critical numbers, one on the right, and both of them are t critical because I'm doing the t-test. And then I will shade my rejection region on the left and right. And remember, nothing else I will do by hand. I'm using the spreadsheet, so I will say this is t data, and I will find that from the spreadsheet as well. So let's fill in the blanks in the spreadsheet. So we are doing the t-test. We know that for this problem, the sample size is 49. So go ahead and change it first. Then we will talk about the sample mean. The sample mean is 15. The population mean is 16.1. Sample mean is 15. Population mean is 16.1. Standard deviation is 25, and that's sample standard deviation, so 25. I am doing both tell tests, so put 0 there. And significance is 0.01. So see how I get two critical numbers. I get the critical number negative 2.6822 and 2.6822. First information, negative 2.6822 and 2.6822. And then I try to find out the t data. The t data is also calculated. It is 0.308. 0.308. Is it in the rejection region? Well, unfortunately, this one is not in the rejection region either. If this is 0, then it is somewhere here. That's your t data. And that is 0.308. So we're not going to reject the null. Answer of testing is do not reject the null hypothesis. Then we're going to interpret. And at the level of significance, this one is 0.01. So at the level of significance, 0.01, there is not enough evidence to reject the null hypothesis. So I'll just go ahead and say that to reject H naught, which says that the existing mu naught is equal to 16.1. The average size of small business is 16.1. Should not be rejected. Answers my question. So this is pretty much what we wanted to talk about, testing hypothesis. And I have listed some of the practice problems from your textbook. You can keep working on them. You also should work on the assigned problems. And if you have any further question, please let me know and I will get back to you as soon as I can.